Hello everyone, I am Parikshit Saikia and welcome to an exciting session on Unacademy CAT-alyst. In today's session, we are going to talk about some of the most frequently occurring questions in the OMATs, the Other Management Interest Test, be it the SNAP, be it the IIFT, be it the Maharashtra CET. So there are certain kind of questions, certain topics which are very important, and from the perspective of the preparation, right, when it comes to these OMATs, it is a must that you go through such types of questions. So today, the next 15 minutes, we are going to talk about some of the very important questions which have repeated several times in the past in the management entrance examinations. But as always, the first thing I'm going to tell you is give me 5 seconds to ensure that I'm streaming live before we get started with today's session. Okay, I think we are streaming live and we are good to start. A small notification at the start. A beginner's batch exclusively for CAT 2021 starts on Unacademy from 21st of December, which is tomorrow, right? So the educators, as you see, Ravi Prakash for LRDI, Shavana for VARC and Bharat Gupta for Quants. So if you are a CAT 2021 aspirant, you might wish to enroll for the same, and while enrolling, you can always use this code, right? You can use this code Parikshit Saikia. You get 10% off on the subscription fee. Okay, let's get started with today's session. Okay, one more thing. We have a free class schedule for today which I am taking, right? LR. Remember, on YouTube, I am doing Quants. For LR, which is equally important and highly scoring, I am taking classes on Unacademy. Absolutely free classes. So the class is scheduled for today. Today, 5:30 p.m. It's an absolutely free class. You can go to my profile on Unacademy. My name is Parikshit Saikia. And 5:30 p.m. you'll be able to see, just filter on special, okay? When you go to my profile, there are a lot of classes. Just filter on special. And then you can view this class live at 5:30. Make sure that you view it live because we are going to discuss blood relations, direction sense, syllogism. These are questions which are very important when it comes to the SNAP, when it comes to the IIFT, when it comes to the Maharashtra CET, IRMA, right? So very important. Remember, starts today, 5:30 p.m. And in case you are a new user, you can view a lot of my other classes also for free. When I say new user, I just mean to say you need to register with a new mobile number which has not been registered with Unacademy before. If you do that, register as a new user with a new mobile number, you can use this invite code Parikshit Saikia. So if you use this code, you can view a lot of my other classes also absolutely free. Let's get started with today's session. Okay. The first question is on your screen, right? Okay, have a look. Out of all the M.B.A. aspirants interviewed, 50% of those who attended the first interview received the call for the second interview. Okay, so I think moment I read percentage, I realize it's a question from percentages, right? 50%. So let's assume that the total number of people is, let's say, 100. Okay, how many get a call for second interview? How many get a call for second interview? 50%, right? So obviously 50 people get a call for the second interview. How many do not get any call for the second interview? The remaining 50%, right? No worries about this. Next, 90% of the people who got a call for the second interview felt good. So 90% who got a call for the second interview felt good. So 90% of 50, how much is it? 45. 80% of the people who did not receive a call for the second interview also felt good about their first interview. You know what? You give an interview, a lot of people, even if you don't clear the interview, you felt that you have given your best, right? So 80% people did not get a call for the second interview, but still they felt that the interview went well. So how many felt good about it? 80%. So 80% of 50 is 40. Right? The question is, if a person felt good after his first interview, what is the probability that she will get a call for the second interview? Remember, person feels good. So how many people are feeling good after the first interview? 45 plus 40. What do you need to check? You need to check for the probability that a person gets the call for the second interview, right? Among the people who are feeling good. So how many people are feeling good and also getting a call for the second interview? 45. So 45 divided by 45 divided by how much? 85, right? It is just over 50%. So your answer is 53%. Your answer is 53%. Got it? That's the first answer. That's your first answer. Easy one, provided you assume the correct numbers. Remember, I started with 100. You can start with any number of your choice. You can start with 200. You'll get the same answer. Let's go to the second one. Let's go to the second one. Okay. 4 blocks of chocolates of weights. So you have given 4 blocks of chocolates, right? Of weights 6 1 by 8 kg, 10 1 by 2 kg, 8 3 by 4 kgs, 3 15 by 16 kgs, respectively, were bought for a birthday party. The blocks were divided into pieces such that all the pieces are of the same weight. What is the least number of pieces that can be obtained? Now let's simplify these numbers further. 8 into 6, 48, 48 plus 1, 49. So 49 by 8. Next, 10 into 2 plus 1, 21 by 2. Next, 35 by 4. Next, 48 plus 15, 63 by 16. Now remember, these are the weights of the cakes. Now you need to ensure that there are least number of pieces. Think about it. The pieces should be minimum. Think about it. If the pieces have to be minimum and they are all of the same size, can I say the pieces have to be as big as possible? Will you agree? As big as possible. Only if the pieces are as big as possible, you will have the least number of pieces. How can you get the biggest pieces? And you know what? The pieces have to be of the same size, right? So basically, I'm looking at a factor of these numbers. Will you agree? Factor of these numbers. What factor? The highest factor, a number which divides all these numbers and is the highest possible such number, right? So it's nothing but the HCF of these numbers, right? How do you find out the HCF of a fraction? HCF of a fraction is HCF of the numerator divided by LCM of the denominator. Divided by LCM of denominator. Correct? HCF of the numerator. Can you find out? 49, 21, 35, 63. What is the highest number that divide all the numerator numbers? 7. What is the LCM of the denominator? 2 and 8. LCM is 8. 8 and 4. LCM is 8. And 8 and 16. LCM is 16. So you get the HCF of these 4 numbers as 7 by 16. 7 by 16. Now remember, this is the weight of one piece of cake. This is the weight of one piece of cake, right? One piece. So it means every cake, the size of every cake, every piece of cake can be 7 by 16. Now they are asking how many such pieces can be obtained. So very simple. How many pieces can be obtained? Can I say total size of the cake, total size of all the 4 cakes together divided by size of one piece will get me the number of pieces? Will you agree? Total size of all the 4 cakes together divided by the size of one piece will get me the number of pieces. Will you agree? Yes. So can I write down the total size of all the 4 pieces, all the 4 cakes? 49 by 8, just add up the numbers. 21 by 2 plus 35 by 4 plus 63 by 16. So this will be the total size of the 4 cakes put together divided by the size of one piece. Divided by the size of one piece. I will leave it for you to do the maths. You'll get your number as, you'll get your answer as 67. 67. That's your answer. Got it? It's very easy, right? So total size of all the 4 cakes together divided by the size of one piece. Answer is 67 for the second one. Any doubt in this? I think we are fine, right? Let's go to the third one. Let's go to the third one. Let's go to the third one. Find the number of 3-digit numbers which are divisible by neither 2 nor by 3. Neither 2 nor by 3. Okay. So I think whenever there is a negative condition, it is always easy to think just the reverse. When I say reverse, total such numbers minus the number of numbers which are divisible by 2 and 3. I'll get my answer. So total 3-digit numbers, can you tell me how much are they? Total 3-digit numbers. So total 3-digit numbers is from 100 to 9999. Will you agree? 100 to 9999. So how many such numbers are there? There are total of 900 such numbers. Correct? Next. Numbers which are divisible by 2. So let's count the numbers which are divisible by 2. Okay, numbers divisible by 2. Okay. Now, can I say the smallest number which is divisible by 2 is 100. Then 102. Then ... The last such number is 998. 998. Right? So what will you get? This is nothing but an arithmetic progression with a common difference of 2. Arithmetic progression. So can I say any term or any term, or for that matter the last term, is equal to first term plus n minus 1 into d. Will you agree? This is how you find the nth term of an arithmetic progression. Nth term can also be the last term. So can I say n minus 1 into d will be equal to L minus A? Yes. Implies n is equal to L minus A divided by D plus 1. So that's how you can find out the number of terms. That's how you can find out the number of terms. Let's find out. So what is the number of terms? Use this. L minus A. So last term minus the first term divided by the common difference, which is 2 plus 1. So how much it is? 898 divided by 2 plus 1. Right? So how much this comes out to be? 244 is 88, 449 plus 1 comes out to be 450. 450 numbers are there which are divisible by 2. Yes? Next, let's take the next case. What is the next case? Numbers which are divisible by 3. Exactly the same logic. 99 then 102 is the first number which is divisible by 3. Next 105 ... The last number is 999. Right? Again use the same formula. Number of terms. Last term minus the first term divided by the common difference plus 1. How much will you get? 897 divided by 3 plus 1. 897 divided by 3 plus 1, right? 9, correct. So 329s are 87, 27. 299 plus 1 is 300. Right? Next, you know what? Some numbers you have double counted. Which are the numbers like 6? A number like 6. Obviously 6 is not a 3-digit number. But let's take an example of 6. A number like 6 is divisible by 2 as well as by 3. So you have counted twice. So basically all numbers which are divisible by the LCM of 2 and 3 you have double counted. So obviously you got to subtract one time. Meaning all numbers which are divisible by 6 subtracted one time. Which is the first number? 102. 108. Which is the last number? 996. Right? So how many numbers are there? Use the same formula. 996 minus 102 divided by the common difference plus 1. Right? So this gets you 894 divided by 6 plus 1. So how much this is? 6 14s are 84, 54. 149 plus 1, 150. Got it? So how much are you getting? You're going to add this, right? 450 plus 300 plus 150 minus 150. This is minus, right? You're going to minus. So how much are you getting it? 750 minus 150 is 600. So there are a total of 600 numbers, right? There are a total of 600 numbers which are divisible by 2 and 3. 2 and 3. So obviously the question is just asking the opposite. Not divisible. So total numbers, remember, was 900. Total numbers was 900 minus 600. 900 minus 600 will get you the answer, right? Total minus numbers which are divisible by 2 and 3. So 900 minus 600 is 300. Answer is 300. Got it? Easy one. I would say easy one. Chalo, I hope you have understood this. Let's go to the next one. So these are questions which have repeated several times in either the SNAP or the IIFT. So questions which have been picked up from previous year papers. Number 4. All the 2-digit natural numbers that have their unit digit greater than the tens digit are selected. If all these numbers are written one after the other in a series, how many digits are there in the resultant number? Now think about it. Let's consider a 2-digit number AB. AB. You know what? They are saying the units digit is greater than the tens digit. So basically, you need all numbers where B is greater than A. How many such numbers are there? Right? Think about it. Let's start. If B is equal to, let's say, 9. Remember, they are all single digits. A and B are both single digits. See, B is 9. What can be the value of A? Remember, A has to be less than B. So can I say A has to be from 1 to 8? Cannot be 0. Remember why? Because a 2-digit number cannot start with 0. So A cannot be 0. Can it be 1? Definitely yes. 2? Yes. So A can be any number less than 9. Perfect. So A can be from 1 to 8. So basically we are looking at 8 possibilities. Similarly, if B is 8, how many possibilities? Remember, A cannot be 0. So A can be from 1 to 7. It has to be less than B. So how many possibilities? 7 possibilities. Similarly, if B is 7, what can be the value of A? A has to be less than B. So obviously it can be 1 to 6. Perfect. You got the logic. Perfect. That's it. You got the logic. This will continue, right? This will continue. So the last value of B is 2. B cannot be 1. B cannot be 1. Why? If B is 2, A is 1. B cannot be 1. Why? B is 1. A has to be less than B. In that case, A has to be 0. But remember, 0 is not possible. So here just one possibility. So it's just about adding up these numbers. 5, 4, 3, 2, 1. So how many possibilities can you add up? 1 to 8. How many possibilities? 3, 6, 10, 15, 21, 28, 36. So the number is 36, right? 36. 36 such numbers exist. 36 numbers exist. Now, what is the question asking? How many digits are there in the resulting number? Remember, you are writing down all such numbers. So, there are 36 such numbers, meaning how many digits? Remember, every number is a 2-digit number. So, the number of digits will be 36 into 2. So, how many digits? 72. That will be your answer. Did you all get it? 36 into 2, which will get you 72. So remember, numbers are 36. Question is not asking how many numbers. Question is asking how many digits. So every number is a 2-digit number. So 36 into 2, 72. Got it? Chalo. Next. Let's go to the next one. Let's go to the next one. Number 5. When you reverse the digits of the number 13, the number increases by 18. How many other 2-digit numbers increase by 18 when their digits are reversed? So let's say the original number, okay, let's say is, remember it's a 2-digit number. So I can take it as 10x plus y. Right? What about the reverse number? What about the reverse number? So it will be 10y plus x. So original number you can visualize it to be xy. Reverse number you can visualize it to be yx. Perfect? Chalo. Now let's look at it. They are saying if you do reverse, the number increases by 18. So can I say reverse number minus original number is equal to 18? Is equal to 18. Correct? So reverse number is 10y plus x minus original number, which is 10x plus y. How much is this? 18. So 9y minus x is equal to 18, or y minus x is equal to 2. Perfect. You got it. Y minus x is equal to 2. So how many equations will satisfy this, right? How many numbers will satisfy this equation? You can just count. So y can be 9. In that case, x is 2. Y can be 8. In this case, this is 6. 7, 5. 6, 4. Then 5, 3. Then 4, 2. Then 3, 1. Remember, it cannot be 0. 2, 0 is not possible. Why? A 2-digit number cannot start with 0. If x is 0, you are basically telling me the number is a 1-digit number. Not possible. Now here also, you look at the question carefully. People go wrong even at this step. You know what? They are saying, they've already given you example. The number 13. Remember, Number 13, when you reverse, so basically they are already talking about this number. They are already talking about this number 13, right? So obviously you don't count this number. Remember 31, but the original number is XY. So 1, 3, 13. They are saying how many other numbers satisfy this condition. So obviously you cannot be counting this because this the question already gave you an example. They are saying how many such other numbers. So you have to count the remaining numbers. 1, 2, 3, 4, 5, 6. So how many such numbers exist? 6. Answer is 6. Got it? Answer for this is 6. The previous one was 72. Got it? I hope you all understood. I hope you all understood. Remember, it's very, very important that you don't make a silly mistake, because if you count the last one, it will become 7. But 7 is the incorrect answer. They are saying other numbers. Okay? So that's it for today. I hope you have liked the session. In case you have liked the session, the only way I can get your feedback is if you hit the like button. Because the like button tells me that you have liked the session, you have benefited from it, and we can come out with more and more such sessions on YouTube. Okay? So in case you have liked the session, do please hit the like button. And remember, there is a free class, absolutely free class scheduled on Unacademy today evening at 5:30 p.m. 5:30 p.m. for free. For this class, all of you will get access. For a lot of my other classes on Unacademy, if you register as a new user with a new mobile number, okay, on Unacademy which has not been registered before, using this code, Parikshit Saikia, okay, it will ask you for an invite code. Just put this code and then you will get a lot of my other classes also absolutely free. But today's class, definitely all of you will get it for free, 5:30 p.m. It's a 1-hour class. Remember, we are doing Quants on YouTube, and if you want to know more about LR, my way of teaching LR, definitely join me live today at 5:30 p.m. So till tomorrow morning, it's a goodbye from my side. Stay safe and keep preparing. Remember, hard work always pays. Thank you so much, and I see you in my next session.